Hi, Kuldeep. Hello.
Good morning, sir. Good evening, sir.
Yes.
मैं तो मैं ही आया हूँ, क्या कोई आया नहीं क्या अभी तक?
एक मिनट. Just give me a second.
हम्म,
Yes, Kuldeep. What are you saying?
हेलो
You're saying something, Kuldeep? Hello.
हेलो
Kuldeep, you're saying something?
ना ना सर, ऐसे ही जस्ट पूछ रहा था.
Okay, okay. So we'll make sure. Oh, awesome. Hi, Vignesh. How are you? All good? Let's just 2 minutes wait.
हेलो
People are joining. Hi, Vignesh.
हेलो
Hello. Are you getting my voice, Vignesh?
वॉइस ऑडिबल सर?
Yes, little. I think it is echoing.
या हेलो जय सर.
Yes, your voice is echo. It's happening. Like
Okay,
echoing.
okay, just yeah, you can please allow me the share the screening, no? That's why I am
Sure.
to
Let me open that. I will allow. Yes, now you can share. Divan also have some doubt. He did not come yet.
Yeah. So my first is one.
Yes.
So I have created all those wherever I need the node element, all those things I have done this.
Okay.
Okay, then wait.
Why are you using this? You have right side viewpoints available. The right corner. Do not need to go in that. Okay. But still, if you are using.
Okay. Then
Yes.
I have the creating the property, material property is done. In section property, I have section
PCSCI.
property, I
Okay.
have
You are using
yes,
composite,
I
I
have
think.
created.
Okay,
Yes,
you are
here
using
is
this one. This is also fine. What I'm telling, this you can use, but in this, if you have monolithic structure, monolithic means your slab and girder going to cast on same time. What will going to happen if you do not going to design in Midas? This section is fine. Only you are going to extract the forces from Midas. That is also fine. This section, if you are using.
Okay.
This is for analysis purpose, that is fine. And if you are checking the final stresses, that is fine. In this, you cannot able to differentiate a construction stage in which slab will come after 15 days or 28 days. It will always construct this, make it as a steel, this my RCC, whatever the girder, PCSC, and top slab will going to come monolithically. They will come together, not different parts. Because it is right now combined section.
Okay,
if you want to do preliminary design, this section is fine. Or if you are direct,
then we have to go for this one.
Yes, if you are calculating the stresses, or you are doing design from the Midas, then you need to consider the PC. This.
I need only the forces, because
If you need forces,
I want to do the curve span.
Okay.
No, I want to do the curve span. Before that, I am just doing trailing in my straight span. With the straight span, the moment
did you
will
ask the
come
question
as
about
it
the
is
curve span
aggressively.
to me, or Divan asked me the question about the curve span? Maybe I can tell you generally in what will happen in the curve span. Your girder will be the straight. Okay. Let me tell you some theory about curve span.
No. Okay, sir. I will come to that point. I am just. Yeah, I will show that. The second point is so this is a mid one I created and the end one I also created. So as of me, no,
Okay,
it
no
is
issues.
automatically assigned. I don't know how to unassign it automatically. Second thing, if I create the tapering portion,
Yes.
if I create the taper portion, just
Good.
tapered.
Good
In
tapered.
tapered, I am
It
creating
will creating
PSCI.
you.
Yeah, this one is correct. Then section I and J. I have selected end support
Yes,
input.
it will give you
Then I
some
have
maybe error.
created. No, one side is coming okay.
Okay.
That
Press
means
it.
support to mid section, it is
Press.
it's
Okay.
creating automatically.
No.
Yeah.
No. Y axis variation. You can see cubic and parabolic. Why it is coming? Okay. No. Okay. Listen.
Oh.
First of all, your section is not that much accurate. If you look at the sizes, can you see sizes? I'm not seeing accurately. Your web is your top flange is
Here,
not matching the top flange of another section. Can you see clearly?
no, sir.
Just
Here,
less.
I have tried more than 1 hour. I have wasted my time. See,
I
BL2
got
is
it. I got it.
1.3.
I got it. Generally, that happen with everyone, not for you also. Initially, I also
Yeah,
faced.
yeah.
Okay, let me give the control. I
Here
can have.
BL3 is 1.3, and here also it's BL2 is 1.3 per.
You cannot
Okay.
use 2 seconds. Can you give me the controls?
Yeah, I
Yes.
given.
It is little slow. I think my net is slow. Your net is slow.
Your internet is little bit slow.
Generally, it happen because of slow nature. Because first, I want to see. Can you show me the property of that left, mid left, and close
Sure.
this? I will stop it. How to stop? That is
Point 2 is the
okay.
slab
Give up
thickness.
control. Okay. Yes. Here, what I'm trying to tell, BL2. This you have given 0.9.90001. It should not be
Yeah.
0001. It should be 901. Put it 901. Do not go in that much point. 901. That is fine. And show me that other one properties. That's why I've also show you here 1.3. Anything is matching it with this? Nothing I am thinking.
No, this one I have confident, but this one H3 HL3 in that I am given 1.1. But here I
That
don't
is
have the taper section, the 10 portion.
I got it. No issues. I'm not concerned about that thing. I am considering about BL1, BL2, and BL4. Just keep in mind BL1.4 or 1.3.41. Can you go or take the screenshot of it? And again, maybe I will take the screenshot. If so, we will
Yeah,
able to
just I
remember
will
it.
start.
That's how we need to see the two properties. Only the
Okay, it will be
bus
there.
fine. Yes, it will be here. Now open the
Okay.
another one property. You do not need to.
It's also
Yes,
1.
here. BL1 is how much? 0.185. First of all,
BL1.
your BL1. BL1
Yeah,
is
it's
not.
a mid portion. I have
First of all,
375. So here the BL1 will be half of.
I got it. Your phone. Can you open that thing in the side view? Something in one. What do we have? Because 1.3 BL2 is 1.3 in that also. Can you open the screenshot?
Yes, sure. See, yeah. Yeah, this is that
1.3 and BL4 is
1.3. BL4
okay.
is 0.401.
0.401. Here change
So here
also
also I need to
BL2
update
into
40.
1.301. That no, that is 401 is fine. No,
Okay.
do not change. Equal. 0.4. It is fine. 0.9 is fine. Do not equal. Little bit different. 1 mm difference should be there. That's what I'm trying to tell you. So put it 901 to this 9. That is fine. 1.3. Change it 1.3 into 1.301. At here, maybe change it at here. Maybe it will able to take it.
301.
Yes. Okay. Now try to create the tapered section. If you tapered, we need to go to tapered. PCSCI. PCSCI. Now here, select your import section. Fine. Okay. Now just give it any name or show calculation results. If it taking the property, you can check also. Check calculation result. Now it is coming. Yes, now working. Just give it any name.
Now working.
Problem solved. Na? This is
Yes,
a
ma'am.
solution. Both sections should not have equal dimension. Simple as that. 1 mm difference should be there.
Okay.
That
And
is
the
the main
same
solution.
way,
Yes, you can
yeah, and
import
I
one
should
in the
say.
different one. Yes.
So,
Now your second point is about it is automatically taking properties. You are saying now?
Yeah, first point is taking automatically. Second point I gave the I
No,
got the error.
it is solved now.
Now
I
I
think.
will the
Yes.
that is solved. Let me know this one also. Then end this improved.
No. Here parabolic, you have click on the y-axis variation. Y-axis variation should be linear. This should not be parabolic. It just comes into your balance cantilever structure. Linear. Fine. This is also linear.
Cannot
Something.
calculate the stiffness.
Something. Check the centroid. When you check centroid, click on the centroid. Not the center. Not the. It is taking something. Okay. Just press OK. No issue. It is. What is it saying? Calculation result cannot calculate stiffness. Section dimension have been incorrectly entered. I need to see maybe due to this pressing the linear something has changed or not. Can you close it? Okay. Just show me again. Do not click on that. Can you go above and again import and export? This is support to you have done it. If one is created, other one is also go above little above.
Another
Symmetric. Okay. Here J1, J2 unselect the J1, J2 is requiring. I think in previous you have selected or not. I do not remember.
Previous is selected, no?
Okay, selected.
Let me check.
You can open that.
I didn't do anything previously.
It is now it is automatically have been selected. Can you close and again try to do it? But do not select that linear one. That do not change. I just create again.
Let me check, sir. Here linear will be there.
These should be linear. I know. If you do it, I know what kind of tapering will going to happen. It is parabolic or cubic tapering will going to.
Okay.
Now,
So here import.
yes.
First I need to import the midsection.
Okay.
Import.
Got it. No. I got it. I think I know why it is happening. Okay, click.
Then midsection.
Just click OK directly. Do not go anywhere. Name it. Invalid section name. End to mid. This is also okay. Mid to end. Okay, fine. Okay.
No, same error. Section dimension is.
Just go through the dimension BL4. Here, change BL4 into 40.40.4 and upper. Just change it to delete one. Delete this 401 into 4000. 0.4. Okay, fine. Now click OK. And go above. No issues. Go a little above. Because both section property will be here. Put 0.401. 40401. Can you press OK? Check OK. If it's taking, still it is saying something 901. No, this is 1.3. Okay, it is still not taking. Something software is doing, but should not be here. Okay, it is automatically taking. Everything is there. If one section is created, You know, there is also option 2, but I do not want to use that option. If you do the PT, that is, if you're not doing PT, what you can do, you can model your selection opposite direction, and it can take from left to right and right to left support. No issues with it. You're getting my point?
No, sir.
Like
Pardon?
opposite modeling of that particular section.
Opposite modeling. We have to create the
Only
line
at
from the
that tapered, only on that particular section, like only on that particular tapered location, not all the things. That
That's
is one
okay,
solution,
but
but do not put this cubic parabolic. I know what will going to happen,
yeah, that
but
is linearly only, sir. That's not
linear,
parabolic.
always linear. Okay, here
Why
top
it
is
is
1.3, 1.301. Go to convert this into 1.301. Maybe we will change also 1.3. Press OK if it's taking. Still not taking. Something it is not. We need 1031. Not okay. That's what I'm trying to do. Both are equal, or maybe put 1.30 this thing, and this is also 0.4. 0.4. Yes. Now go press OK. This is also 0.09. Press OK. Okay. Just use it. Now change the bottom one only. Bottom 1.1301 is fine. 0.40. 301. 301. And this 0.40. Okay. It is still something is not able to taking account, because one section is created. I do not able to see if something not this. Generally, it always happen due to the BL. Your thickness is in the web, not with the flanges. This tapered property always create some error in. Okay, you can send me this model. I can give you, no issue. If some problem, I can find you even send you. But I tell you, if you want to create tapered one, you can create those member in opposite direction. Just delete those member and recreate that in opposite direction. That will solve only in your analysis. If you want to do the PT, then this will not work. For the PT design or cable arrangement, we require all element in one direction. So that is a must condition. But
yes,
in this,
then how can I
yes, tell me.
Automatically it is assigned full or?
No, that is fine. It automatically assign it. But if you want to change it, select that element and drag and drop property. You getting my point?
Okay. So which element no,
first of all, go to line model.
How?
Go to line model. Go to line. Yes.
Okay.
Now select here. Click on the selection material. You know that always I click on the yes. Now which member you want, which property? No, first of all, do not select the members. Select member. Select anything. Now this member is also selecting. Do not select from the left to right. Select it from right to yes, like this. Now drag and drop that property. Drag, yes, it will be applied to this member. If you want to change another one, create property and drag and drop.
Okay, but why it is automatically assigning for all?
What is happen generally when we do not assign any property now and we create one property. So Midas have this kind of internal system. It applies one property, all the member which are available. So afterwards, when we create different property, we need to update our model. Midas does not know that you created other properties for other element also. Then we need to give command. Same in listed, but listed do not take any property. Instead, we need to apply every property differently. But here it just take automatically by default first property to all the elements.
All the elements. Okay.
Yes, first property only. But then afterward you can change every property or everything, but just by simple selection and by drag and drop.
Yeah, then I'm showing that curve span you are asking, no, sir.
Yes.
Yeah. So this one, what I did, I have.
Do you have drawing?
Some
if it will be best, I can guide you with the drawing if you have.
No, just I created from AutoCAD.
Any Flickr. Okay. No, I just need to show me this AutoCAD drawing. So maybe I can tell you if you're doing correct or not. Because by drawing we can see I do not even require the model. I can easily tell by drawing itself. Okay. Okay, does not look good. Okay, looking good. Your span girder should be straight. Yes, show me the top view. Top view.
Yeah.
Yes. It will look like this. Fine.
Yes, yes.
Yes.
Now what is our problem? So
Tell
here
me.
the cantilever will be 2.4.
Yes, it can be
So
possible. Fine.
yeah. So in STAT model, we did a straight model only.
I
Same
know.
like that only we did, but we run
Instead, you can only able to do
the
skew or straight. Yes.
yeah.
Okay.
So we run the vehicle in straight portion. So we got
Got
the
it.
huge bending moment. So at the same manner, if we do the same model in
Now
Midas,
you can very easily do it in Midas. You just need AutoCAD, and I can not take more than 4 hours for whole model.
yeah, sure.
Everything.
So
But I
that's
will
why
tell
I modeled
it is
here.
still
So
it is still wrong. But I'm trying to tell you why it is still
mm,
wrong. First of all, this the transfers you have created, that is fine. You try to create a perpendicular one, but those are not looking that much good also.
no,
What you
that I
need
will show you
in
that. I will show
show
you
me the
that in
drawing.
AutoCAD drawing.
Drawing. I will tell you what happened in the Midas itself. What is this ACT CAD? Some different software.
Yeah, it's an Indian company.
Okay. I know about one other CAD. I do not. I forgot the one ACT. I think. Yes. Now you have done like same. You can directly paste it this thing in your CAD itself, in Midas itself. That is fine. But
Hmm.
actually, what is going to be happen? That's what I'm telling. I got your situation also, and what I'm trying to tell you. Previously, I also told you your end girder have more length as compared to your mid girder. Then another end girder have less length. First of all, I want to know
Yes.
why those two piers are skewed in different directions. It is side requirement. Why it is making
Yeah,
a
it's
cone shape?
just
It will be same. Will be there. Not going to change this direction. Okay.
no. This
That you
is
are telling.
down ramp. This is down
Okay.
ramp. We have to give like this only. We don't have any
Okay.
option.
Okay. That is fine. If it's a down ramp, you do not have
You
any
can
option.
see here.
I got it.
So
I
this
got
is
it.
the down ramp. So we don't have any option
I
to.
no,
Initially,
I
they
got
have
it.
given the box girder.
Box is
So that
best
is some more.
always.
Box is best, but they are asking me, no, it is very 6.5 meter only now. So they
Okay.
don't have any
Okay.
shuttering for that. So
I
they
have
don't have any
one.
shuttering for that, but say that only they are asking girders.
I
So I
got it.
have
I
done
got it.
this model in STAD also, but it's getting a huge.
No. I will. I can model it if you can give me. Just tell me first of all. I will tell you. I will sharing my screen. You can this. Stop your sharing. I will tell you some basic about what will happen in this kind of modeling and how you get the wrong result. First of all, why you are getting wrong result and why initially everyone get the wrong result. Even if I'm not that much experience and I have not seen the curve bridge, I will get the wrong result because I have already seen it and done it. What is happening? You have one pier cap. You can see my screen now.
Yes, sir.
You have one pier in this direction and one pier in this direction. That is how pier cap is look like, and your bridge is moving like this in this curve. Okay, like this curve and this curve. Now, basically, as per our girder methodology, our girder will always be straight. So you provided like this point to this point, one girder that you have done, and then one girder is here. Then last is, let me delete this straight. I can able to make this straight. This is your one girder. This is your one girder. This is your one girder. Now, what is happening in STAD? You cannot even able to model the curve span. You can only have a straight one. Then you try to run the most eccentric point of loading, and it is giving maximum moment at this location. That is happening in STAD because it is also creating torsion. Lot of things are there. STAD does not properly able to analyze your curve span bridging. And Midas, you have provided like this kind of transverse bracing also or transverse member. Okay, that is also you can say not correct in the Midas modeling. What is going to be happen? You need to provide one central line or something through in the curve portion. Let me show you. Maybe I can show you one model also. Just give me a second. Before that, what is going to be happen? Your vehicle will not going to be straight. Your vehicle will go like this. You're getting my point? Your vehicle always going to be moved like this. So we need to produce that behavior very accurately. We do not require any other behavior. So let me show you one example. Give me 2 minutes. I need to connect one drive to show you.
Like box girder, that curved one you stay line model you did know, sir. Like that in curved only it should be there, no, sir. Hello.
And in this, I think Vignesh, in your arrangement, this girder will have more. You need to design for more PCSC force as compared to this one and this one. First of all, this is the bigger one, and you are getting more cantilever in this portion. All three girder will not be having the same kind of PT or reinforcement.
G1 will be critical, no, sir.
Yes, this one. G1.
We have to give different PT, different PT.
Yes, that's why I'm showing you this model. It is pretty much your based on this. You can see here, these are my eye girders. Skew eye girder, and bridge is moving like this. You can see these lines. So my bridge is in the curve direction. And I have provided skew eye girder. Then we have to provide this curve nature. Because one is fine going in this direction, but this is they do not ask to provide any box up because this is a single span bridge. So they never ask for box. So eye girder, they are going to put lot of eye girders. Not even if you look at the 3D view, maybe I can show you. So that's what I'm trying to tell you. You need to create that kind of curve lines to model accurately your live loads. and you can provide directly the straight these your transverse member. Now, if you look at it, that's how bridge is moving. This portion is totally empty. Nothing is there. My slab is only at this location and at this location. And if I go into the live load, I can share with you this model that what I'm trying to tell you. Where is my moving load? Maybe I can also show you from this thing. Moving load. You can see curve skew display. That's how your moving load will move. Not like a
Straight lines
straight.
are for what purpose, sir?
Straight are my girders, man, not purpose. These are girders. You can see another one.
No, this curved portion, curved lines are girders, no, sir.
No. Curved lines
Curved-
are my road. That's what I'm trying to tell you. Your
Okay.
curved lines are road. Straight lines are your actual girder. So your live load is moving in curved direction. So what you need to do,
Okay.
you need to provide one curved line in the center, and then you need to model all the live load according to this line. That's how you will get. If I go into here, let me see the property.
Then
Like
how many
this
girders
in
are
the-
there, sir? Here.
And also this they will cross this cross beam, but your path will be in curved direction. Your path cannot be straight. Like
Yeah.
what I'm generally what will happen previously when this Midas was not available, we always try to do a straight one a little bit, maybe consider little extra moment here, because stat does not have that much property available, or you cannot play very much with the coordinate. We can model the skew one, but not curve is pretty much very difficult. Or then in stat also it is possible. Then you need to provide your x and so z increment very accurately that it can able to interact the actual behavior of your curve. So what is happening here? In your case, first of all, you will model this all things. You will provide these, what I'm telling, these as a straight member. Your cross member should be straight, all cross member, like this. You can see cross members of all are straight, like this.
Okay, sir.
And then you need to provide a curve line. One, maybe imaginary line will be there, a dummy line. But you need to provide your live load according to its dummy line. Like here, you will providing maybe for different color I will mention. From the center, if this is my bridge center, so your dummy line will go like this. And you will bound your live load with this dummy line and with this straight cross member. So your live load distribution should be very accurate onto whole bridge. It should not be like this. Mostly will be taken by cantilever or less will be taken by this. Every live load will equally going to be come then girder, but because of this length, they will have some extra load on this outer girder. But actually, your what will going to be actually your whole bridge is taking your live load, not only this girder, but my live load is positioned in this direction, so that's why I have more live load as compared to these two girders. But actually, my slab is transferring live load to the girder, but slab is also connected by another girder and also with this girder. This will also distribute some live load. So that is the main thing in grillage model. We need to distribute our load from the slab to the girder in such a manner that it should not go in one girder only. It should be distributed in every girder. So that you can only able to model properly. If I have the time, I can show you the modeling also. It will not take me that much time, but maybe tomorrow or any other day we can have a also session. Maybe tomorrow, if both you will be available, I can show you how to do that if you are not in this. But Midas will give you very accurate. What will happen in the curve bridge? You get first of all, you need to apply this course. Scientific.
Sir, we'll do one curve model, sir, tomorrow, if it is possible.
Yes, curve we can able to do.
We will give the drawings. At the same
I
time,
can.
exactly. That is PT only. PT
Uh-huh.
only will do it PT only because we are almost stuck in 2 weeks. Into this,
No, I got your point. Generally, if something new come, people always got stuck. It's not a major. It's just how to overcome.
Tomorrow or else
whatever.
we'll keep it in Friday, sir. Tomorrow else we'll keep it in Friday.
Friday, I need to see. Okay, we can able to do Friday also.
We'll
But
check, sir. We'll Friday or Saturday also, no problem.
Saturday I'll be traveling. I have a
You'll be
flight to
traveling.
catch.
Then
Yeah. Sunday I will be free,
tomorrow-
but I'm thinking maybe on Friday.
okay, if it is Sunday, if you're free also, okay, sir. Me and Vignesh sir will join.
Okay, we will have a discussion.
Me and Vignesh will join. So little bit. So
No,
right now only
that's
we are
fine
starting
because
working on
I
this.
know people always stuck in new things.
Once we
because
done this one single model means afterwards we don't have any issue. We will keep
totally.
on going further.
Well, it's not like that. If you have some problem, you can ask me. I have solved a lot of, Meher was
Yeah,
there.
sir,
I have
yeah.
solved a lot of
You are
problems.
experiencing.
issue.
We are only starting.
No, not the experience. I think we are both on the same page. But I am just exposed to different kind of experiences. That is only different. But I know I have my seniors are those are very experienced. I have 25 years of experience. The seniors one, so they are very good. Know about the modeling and every aspect of every bridge. Not in this. They try to elaborate the problem into simple part. They're always like this. So that is the only thing. Nothing
Okay, sir.
I have. So we can have a discussion. Totally fine.
No,
I
sure.
think Kuldeep, Kuldeep, what are you asking?
Sir, there is a Codal clause
Uh-huh.
about the curvature of slab or bridge.
Which slab or bridge? Kuldeep, तुम्हारी आवाज बहुत कम आ रही है.
मैं कोड में कहाँ दे रखा कि ये लिमिटेशन है इतना कर्वेचर ले सकते थे नहीं ताकि
कोड में कोई लिमिट नहीं है. ब्रिज में कितना भी कर्वेचर आ सकता है. कोई लिमिट नहीं. तुम इसको चाहे तो यूं करके यू दे दो क्योंकि तुम्हारे रैम्स होते हैं. तुम्हें पता है ना ब्रिज के जो रैम्स होते हैं. जैसे ये मेरा ब्रिज जा रहा है. अब जो रैम्स होते हैं वो यूं करके उतारने होते हैं तुम्हें. ये जो चीज होती है ये हमारे लिए नहीं होती. ये होती है हाईवे इंजीनियर के लिए. Always curve portion will. हाँ. Tell me.
कंडीशन रहती है या फिर अपन जो बियरिंग पे रिएक्शन चेक करते हैं उसी पे डिपेंड करता है कि
नहीं बेयरिंग पे बिल्कुल डिपेंड करता है. बेयरिंग पे क्या डिपेंड करता है मैं बता दूं. बेयरिंग पे डिपेंड करता है ओवरटर्निंग नहीं आनी चाहिए. यहाँ पे क्या होता है
नेगेटिव रिएक्शन नहीं आनी चाहिए ना किसी भी पॉइंट.
हाँ, ओवरटर्निंग का मतलब नेगेटिव रिएक्शन. वो इसलिए नहीं आना चाहिए. मैं वो भी बता देता हूँ क्योंकि कोई भी गवर्नमेंट टेंशन बेयरिंग अलाउड नहीं करती. तुम ओवरटर्निंग भी अलाउड कर सकते हो लेकिन फिर तुम्हें बेयरिंग जो देनी पड़ेगी वो टेंशन बेयरिंग होती है. वो बहुत स्पेशल बेयरिंग होती है. वो पहली बहुत कॉस्टली होती है और इंस्टॉलेशन बहुत डिफिकल्ट होता है और उनको चेंज करना उससे भी ज्यादा डिफिकल्ट होता है. उसमें होता क्या है कि ब्रिज अगर तुम्हारा ओवरटर्निंग सेल्फ हिट में फेल करने लगा वो तो कभी पॉसिबल ही नहीं है. वो तो तुम ब्रिज बना ही नहीं सकते अगर वो सेल्फ हिट में फेल कर रहा है ओवरटर्निंग में. लेकिन अगर तुम्हारी लाइव लोड की वजह से और सेंट्रीफ्यूगल फोर्स क्योंकि लाइव लोड की वजह से आता है उसकी वजह से ओवरटर्निंग आ रही है तो तुम उसमें क्या करते हैं. हम ब्रिज को कंटिन्यूअस बना लेते हैं. मतलब यहाँ पे फिक्सिटी प्रोवाइड करा देते हैं और इसको आगे फिर ले जाते हैं. उससे ना मेरा स्पैन में क्या होता है ओवरटर्निंग खत्म हो जाती है. या दूसरा ऑप्शन ये होता है कि मैं टेंशन बेयरिंग दे देता हूँ या सेल्फ वेट ऑफ स्ट्रक्चर बढ़ाने की कोशिश करता हूँ कि अपनी विड्थ ऑफ जो स्लैब है उसमें थोड़ा वेट बढ़ा के या कुछ और चेंज करके उसमें खेलूंगा. और वरना दूसरा ये आगे स्पैन आगे पीछे दोनों साइड बढ़ाऊंगा.
वो तो सर हाईवे डिजाइन इंजीनियर बताएगा ना कि हम लोग की डिजाइन स्पीड के हिसाब से मिनिमम रेडियस ऑफ कर्वेचर कितना होना चाहिए.
नहीं हाईवे इंजीनियर सिर्फ कर्व बताएगा कि इतने कर्व में तुम्हें रखना है. स्पैन अरेंजमेंट पूरा हमारे हाथों में रहेगा. हाईवे इंजीनियर उसमें कहीं नहीं आएगा.
कर्व तो वही बताएगा हाईवे.
हाँ, कर्व हमेशा हाईवे इंजीनियर बताएगा. कर्व में हम कुछ नहीं कर सकते. वो हाईवे कोड में है गिवन कितना कर्व लेके चलना है और उस कर्व के हिसाब से कितनी स्पीड व्हीकल की चलेगी. अब गवर्नमेंट ने बोल दिया भाई मुझे तो 50 की स्पीड चाहिए तो अब उसको उस हिसाब से कर्व डिजाइन करना पड़ेगा और सुपर एलिवेशन प्रोवाइड कराना पड़ेगा कि 50 की स्पीड मिल सके. अगर वो नहीं करेगा तो उसकी ड्राइंग अप्रूव नहीं होगी. हमसे कोई लेना देना नहीं. हम तो भाई अपना जितना वो सुपर एलिवेशन बोलेगा उतना लगा देंगे. हमें ब्रिज इंजीनियर को इन चीजों से इतना फर्क नहीं पड़ता कर्व कितना आ रहा है या फिर अपना ये कितना आ रहा है स्क्यू कितना आ रहा है. वो सारी चीजें हाईवे इंजीनियर पे डिपेंड करती है. अलाइनमेंट होता है उसको कहते हैं अलाइनमेंट ब्रिज इंजीनियर के हाथ में कभी भी नहीं होता. ब्रिज इंजीनियर सिर्फ ब्रिज की चीजों पे कंपोनेंट्स पे काम करेगा ना कि हाईवे की अलाइनमेंट पे. आप कोलैबोरेटिवली काम कर सकता है कि हाँ भाई इतना मत दो ये सही नहीं है मैंने देखा नहीं. लेकिन फिर हाईवे इंजीनियर बोला भाई मैं हाईवे इंजीनियर हूँ मैं दे रहा हूँ तुम रख जा रहा है. If I am giving, you need to design this superstructure, substructure, foundation according to it. So we will design it, no issue. Everything we can able to design it. And it's not like that minimum curve in the, everyone I know about this exit loop, entry loop, in every bridge you can see. So there are very much curve and always super elevation will be provided there. So this all things generally given by all the highway people. No limit is there. It is according to the speed of vehicle or speed prescribed by government on this road. Not in our scope, Kuldeep. Any other doubt, Kuldeep, you have?
Sir,
Yes.
sir, this negative vertical reaction in bearing,
Ah.
whether it is allowed or not allowed, sir. For this kind of
That's-
bridges, now in one
No, no,
bearing, a negative force like that, it is
No, not allowed. Not allowed. You need to ask the special permission. If you are getting negative reaction due to dead load, it never be allowed anywhere in the world. Simple answer, not allowed. If you are getting negative reaction in live load, that can be allowed for tension bearing. If tension bearing
For
government can
example,
allow.
here we have two bearings on this side and another side two bearings, sir.
Two bearing
This
or
is
four? You
actually-
have diaphragm bearing or this girder bearing?
Diaphragm, no,
Ah.
diaphragm transfer means
Like bearing will be at this location.
not
If I-
each girder there is no bearing, only overall.
No, this bearing will be at this location, no, which I'm making. Can you see this?
Yes, sir.
I got you.
Total
If you
deck
get,
is 6.5 meter.
that is
total
fine.
deck
If you
6.5
get any tension in any bearing, if you found in your analysis model, that is design cannot be accepted. You
Okay.
cannot. That
in
is
the
known
STAD,
as.
if we are expecting the reaction from the STAD, we are getting negative reaction. That
Model
means
wrong. Bridge is not stabilized. That is what I'm always asked. First, we need to stabilize the bridge. That bridge is not stabilized right now. It is not on the stable condition. What
no,
will
not
happen?
for that load, sir. For live
No,
load
sir.
or for other loads, if it is coming means, sir.
That is what I'm telling. First, your dead load needs permanent loads. If negative reaction coming in the permanent load, what will happen? Try to imagine. When they put bridge onto bearing, it will automatically topple. What will happen? This thing will go like this. Like if you have seen that bridge collapse in the Japan due to the earthquake, it tried to topple it. So in toppling, you cannot able to avoid for dead load. No bearing can able to save your dead load toppling. But sometime what will happen if your dead load does not create this negative, but live load at this location, most eccentric point, and this is creating your negative at this bearing point or at this or maybe any point. I'm not sure which will be the more critical. So for that, generally, then we need to give our designing whoever a or client that you need to provide in one bearing will be tension bearing. And tension bearing, what will happen? You need to provide extra strut in the superstructure for resisting the tension and also extra bolts in your pier cap to resist the tension. And when you want to change that bearing, that is very different case. It is not very easily you can lift that whole bridge. Maybe you require some temporary support in the mid of bridge, then you can only able to change those bearings. Because this will going to be fully embedded in your superstructure and fully embedded your in pier cap. That's why that is the
Like
main reason.
monolithically, it will be inserted both in top and bottom will be fully connected, rigidly
fully
connected.
connected. Yes, that's why they do not. In I will tell you, in Middle East, whole Middle East, single tension bearing is not allowed. Single tension bearing. Like if you're designing for Saudi, Dubai, Abu Dhabi, Bahrain, Kuwait, they never allowed any tension bearing. They simple said, change superstructure anytime, but we will never allow the tension bearing. I got one bridge, a truss curve in nature, but they never allowed it, and then we need to change it into the this balance cantilever fixed piers. So then we cannot, because pier will not going to be collapsed. They have some pile cap, weight pile, everything will be there, and this is totally connected, monolithically connected with the ground. So this will not going anywhere. So that only they have accepted. Otherwise, people, if you always remember, you need to provide the bearing reaction table also. If you remember it in the bridge.
Yes,
I do not know your
fourth table.
if you mention anywhere your negative reaction, so whoever checking the design or whoever purchasing the bearing,
now for
They-
designing the spherical bearings, we need to give the forces to the manufacturer.
manufacturer.
Manufacturer will be
But
designing
if the
the
manufacturer see
bearing.
the negative reaction, he will be shocked that this negative is not good, and bearing cost also going to be increased, maybe 2 times, 3 times. Tension bearing. Tension bearing is not that much easy you are thinking to provide it. Because what will happen in bearing, if someone remember it, we have top plate, some spherical.
Why
like
we are
this.
connecting like that, sir? How it will be here, sir?
What is happening there? You can see now. I will tell you why it is here. If you look, it will be in super elevation like this. Everyone knows that your bridge will look like that kind of thing. You will have
One side will be
girder,
up and one side will be down.
one side will down. Okay. Now what will happen? It is simple, not that much simple geometry. So you will have different kind of pedestal height. This will be small. This will be bigger. Then this will be the highest one. That is main role of pedestal. But pier cap should be straight, no issues. Now, when traffic at this location, the most curve span. Okay, my vehicle at this location. What it try to do? It will apply one extra force in this direction. Radial force. Like if you have any circle and you are applying force in this direction. So always force want to move in a stable position. So this thing want to move in this direction, but our bridge is restricting bridge. What is bridge is doing? They want to move in curve direction. So this is your centrifugal force. First, this force is happening. Other force is your due to this curvature, directly dead load. What is happening in this? Your load is higher on this girder. Your slab has more cantilever at this position. So your bridge is also moving in this direction. You have this force, centrifugal, you have this force, and other force are like wind is also blowing in this direction. Again. So everything is moving against yourself. So what will happen? This will have compression and this bearing will try to topple it. So your bridge will rotate like this portion. Like it will try to rotate in this direction. That majorly happen in very curved bridges. That's why sometimes even curved bridges, we treat them as a special bridges. Because curved bridges have this kind of negative reaction. If you have very steep curve, it is very difficult to design unless you will provide the monolithic. Like what you will do? Best solution for that, you need to do not provide any bearing, provide direct pier reinforcement to your column, like this reinforcement. So it will be monolithically connected with your pier cap, or your diaphragm should be monolithically connected. Like you will have reinforcement of diaphragm with the pier cap. Then you can, that is a basic solution available all around the world. What we do, we provide the continuous bridges without any bearing. Like you do not need, this will have some, you get major hogging at that location. So that is the only solution for resisting if anyone not allowed tension. The other solution is that you can provide the bearing, then again you need to provide the continuous bridges. So continuity will try to resist your toppleness. So that is one thing. Other thing, you will provide monolithic. Last thing is your tension bearing, which can be allowed but need to be discussed with your client or contractor. If they are okay to provide it, you can provide tension bearing, no issue. It's government headache. If they are going to change in future, their headache, not ours. And manufacturer headache, how he will design it, how will he provide it. Tension bearing are there, it is available. Generally, you will find tension bearing in cable stay bridges or suspension bridges, those kind of bridges they have, or dampers, this kind of thing. But in normal bridges, no one wants tension bearing. This is a single 3-span bridge.
At that case, what we will do? If we getting the negative reaction in dead load.
If you are getting negative reaction, first of all, we
can move the bearing spacing.
No. First of all, yes, you can move bearing spacing. And first of all, your model should be correct. If your model is not correct and you're getting negative, so no benefit of moving or adjusting. First, our model should be correct.
We are not getting the negative reaction. We are not getting the negative reaction all over. Only we are getting the negative reaction in the curved portion.
You are getting the curve portion, the negative one. Here it is showing like this.
In normal portion, normal straight span, we are not getting.
You will never get in a straight. Everyone knows. No one. You will always get in the curve portion because centrifugal wind, every force has come, and even seismic, it will also increase the seismic force. So everything work together to topple it. what is happening? This bridge will try to move like this. Not
Sir,
go
let me-
inside. It
let
will
me
try to
show
go
you.
outside. It will go outside.
Sir,
Okay, you can
let-
show me.
let me show you.
Sir,
Yes, yes.
this
Okay.
how it is
Uh-huh.
how
One
it
moment.
this overtoppling it is you are showing now, sir. This direction.
And let me. Direction will be. It will go from inside to outside.
Why, sir?
It will always be like this. Your bridge will bound to move in outside direction. Radial force. Assume a circle and
No,
your
centrifugal force will be acting towards the outside, so that's why it will
yes,
move
yes,
down
outside,
to up.
outside. Yes, yes, it will move down to up. Totally. You can see you will get negative reaction in the inner bearings and compression
sir.
in our.
See
Outer one.
here, this is our bearing position.
Got it.
So bearing position will be bearing to bearing distance will be around 2 meters.
Fine. No issue. Do not show me. Just show me the reaction. And you are using still the older stat VATL.
Hello?
You can update
No,
it
no,
into
sir.
the
No,
correct one.
office person, what they will give,
Okay.
you can use that only. So
It is
here
right
we are
now,
not getting. Here I am
now
not
that
getting
is-
anything for dead load.
but go to
Slab you need to see slab
now
here.
you can slab, but slab is also dead load part. Now combine the
Yeah,
dead
yeah.
load of gutter plus slab. Then you need to see.
Yes.
And plus SIDL also with crash barriers and everything. That is your total dead load. So check in the total dead load.
Yeah, here I am getting minus 59.
59. Even this is not acceptable. Even if I'm getting minus, and you know basic criteria for design of bearing. Does anyone knows how much compression force is required on one bearing or corresponding bearing? I think you know about it. 20 to 25% compression load is required to your corresponding bearings. Like if you are getting 2560, so another load, the minimum load of any bearing, like you will have one minimum load also on this bearing. It should not be less than 20% of this load for design
Okay,
purpose.
at this case, we need to increase the bearing spacing, huh?
If you increase, it still might we get something. Or
Or else
you
you
need to
can go
provide.
with the.
Even you
or else
cannot
you can
design
go
it.
with
I'm telling you, you cannot design it because you are not achieving 20% of this thing
No, sir.
also.
One more thing. If you are not getting like this, we can go for the direct girded bearing transfer. Huh?
Then you need to direct transfer with the reinforcement. But then you will have continuous bridge. You're getting, you will have hogging also.
No. I am asking direct. So each girder will give a direct bearing.
That you need to see.
Here
I
3
cannot
bearings,
able to
here
say.
3 bearings.
That you need to see. That might not provide. Yes, because girder fell weight will be higher. Yes. That is one possibility.
In each girder, if bearing is placed like that is.
I cannot say. You need to check it. I'm not like without analysis model. I cannot guarantee.
You are telling continuous, no, sir. That is how, sir. What way to change that one? We didn't understand what you are telling.
What I'm telling, then you need to provide your girder will be directly connected with your pier cap. You do not
that
have
is
any
one
pedestal.
option. Another option.
Another option is that bearing you can provide, but because after that your span is become straight and thinking. You do not have a curve after this point, or you have still curve. You can provide
two spans of curved.
So make both the span should be continuous, best option. But you cannot make the continuous the eye gutters. Only it is possible in the box gutter. That is also one thing. Because your eye gutter are always straight. You cannot. But one more thing you can check. But I think straightness due to you provided which support. When you have two bearings, other. I do not. You have still bearing on the diaphragm location. You need to delete those bearings. Curve bridges have a lot of problems. And that's why people try to avoid curve with the girder. Try to use the box section. And what about the torsion? You will have a lot of torsion in curve bridges. Then you need to provide extra shear reinforcement as compared to the normal one.
No, sir, they
Vignesh,
don't
you
want
have
to,
four
they don't want
bearings.
to go for new shuttering now.
You can see the fourth one is giving -1. You need to delete that the extra bearings of diaphragms. Model is not
Where I
correct
get
right
it.
now.
Yeah, sir. Curve model, na curve model. It will not correct
We
properly
will
on
discuss. I
slab.
think we can take one time.
No,
But we,
Devan sir.
I will tell you, no one. If
Three
you
girder
show,
means 3 bearings only you put his.
you have, here is 5 bearing,
அப்படிதான்
here is 4
போட்டேன்.
bearing.
எப்படி
And
நிறைய
please
curve
do not
இருக்கு.
submit negative bearing without discussing your senior or anyone to client. Otherwise, they will think, oh, you do not know that we do not allow the negative reaction to the bearing unless you have discussed. Like what you have discussed the bearing, pot PTFE bearing, which have translation free and which have this kind of fixed one direction is the pin, one direction transfer free, one longitudinal free, and one will be free in all direction. But you never consider the tension in any bearing. So that thing they will get like, oh, you do not know this thing. So they will raise question on you, not any other person. So generally that I work a lot of this kind of things. So it should be properly checked internally on itself. That if you get any things.
Sir,
how much the span you have? What is the total span of this?
33 meter.
33
okay, you
33
cannot
meter.
got it. You cannot able to provide the slab, voided deck slab or anything. Now you are not.
Now
getting,
it is okay, sir. I think. Not getting negative.
The total dead load is
but
fine,
the 25% will not assume.
No, that is still.
This is total dead load.
Still, you need to fight it for it. Sometimes they can design it, but it is not acceptable still right now. 20% dead load is not achieved. So our bearing is not in the compression. Not compression. It is like does not have any load on that bearing. So sometimes what will happen for they still design this bearing as a tension bearing and consider zero tension force only this thing.
No, there is some rule, sir. Where it is there in code, it is mentioned 20%.
This is rule as per practice, I know, but I need to see the code. I do not remember it. This rule is as per practice. We are generally with the client dealing and the contractor dealing or giving our.
For example, 1000 kilonewton means 200 kilonewton should be there.
200 should be there. It is because we got queries after submitting our bearing reaction to the bearing designer or contractor. So they said, okay, we cannot able to design it because you are not achieving 20% of load.
Minimum compression we are not achieved.
Yes, minimum compression we are not achieving. So a simple said, then we need to consider the tension, or you need to change your bearing location or stiffness of bridge, slab, anything. Sometimes we increase even the dead load. In what is happening in the truss, we try to increase the dead load to get the toppling, to resist the toppling.
Here, increasing dead load will give anything, sir, positively.
But you do not in India. You cannot able to increase dead load that much because if you are increasing the cost of your contractor. If you change anything, so do not go into that. We will discuss. I think this will able to solve. Midas will able to solve this. Your modeling is not much good, but if you do it in the Midas, then we can able to.
Okay.
We will have a see. No issues.
We have these two spans, sir. Two spans are there, but
we can make a slab continuous, and we need to see if continuity, deck continuity is resisting some, because deck continuity also provide you some resistance in your negative bearing reaction. Not that much, but provide good resistivity. So what you can say, deck will be continuous and weather will be simply supported. Yes, sir. Yes.
This deck continuity extra detailing reinforcement they will provide, no, sir?
Yes. You need to check
how it will be, sir. How it will.
You need to check it for the extra longitudinal reinforcement come at that location, and we need to check it for our temperature cases, basically mainly. Temperature governs for deck continuity.
There is some segment or some girder or whatever it may be in the deck slab portion, at the expansion joint location, no issues, sir.
Expansion or not, but at continuity location, we need to see our forces or stresses, how structure is behaving. So if we are getting higher forces as compared to our design, we need to provide extra reinforcement at only that support location. and some extra, some extra reinforcement in top of slab also.
Yeah. Top of slab there may be hogging at that
Yes,
location.
hogging, not that much governing, but hogging will be there. But we provide extra reinforcement as per our detailing. I have
At
maybe
the
drawing.
can you share it, sir?
Right now, it will be difficult.
No, not now. Whenever.
I can share it. So
for
it is fine.
segment, how they will be providing the deck continuity portion detailing.
No, fine. No, segment is fine. Your girder will have same reinforcement, nothing going to be changed. Only slab will have different kind of reinforcement. Only at that
slab only, sir.
continuous.
Joining portion of slab means one segment and another segment.
I need to take out my drawing where it is there, so I can give you.
Both the end segment while joining at the slab portion, we have to provide some extra reinforcement, na, sir?
Yes.
Okay, sir.
Even this expansion joint, we need to check for extra length. That if you are providing typical 40 mm will be enough or not. Yes.
Okay.
Sometimes. Deck continuity is a good thing in curve span bridges. You will find a lot of there.
But
one more thing.
40 mm expansion joint typical, we have to check whether it is okay, or we have to increase those things also. We need to check. You are telling us, sir.
Yes.
Means whether it has to be 60 mm, 80 mm, how much expansion it will take.
Yes, we need to check for the temperature forces, how much expansion will be required.
Okay.
Because your temperature always going to transfer from your deck only, not from the girder. So that's why
for segment also, whichever it may be, for segment or girder, eye girder, whatever it may be.
From girder generally do not transfer that much. Area is still there, but governs always the top slab. And one other thing is that if you do not able to solve this problem, there is one more thing which is known as steel tub section. So that is very good for curve span bridges. And for one tub, you can easily able to model the whole bridge. But I think contractor will not accept it because it will cost very high.
Yeah. They will not
steel tub generally for higher, more than 30 to 50 meter span, steel tub for curve span are very common. Right now in India also they are adopting it for the curve portion only, not straight. Anyone you can put, but curve, because they can easily able to curve those tub section at the fabrication yard itself. So that's why only. Otherwise, it is very costly. Cost perspective, but if we will discuss it, and I think Ravi or any Kuldeep, you have doubt anything? We're not able to discuss that truss bridge. And
so truss bridge, how much is completed, sir? I couldn't able to follow the remaining
truss bridge. We have provided all the things. We just need to create our construction stages. We have provided generally. If you look at here, that.
Or you can you tell us, sir, what we have done?
What we have done, like previously, I have also mentioned that
modeling I was there. Modeling
is there. I have provided only all the dead loads. Like you will have lot of SITs like slab, ballast, sleeper, rails, fastener, utilities, railing, all dead loads. This will be your
railway.
And then we provide live load railway as per this DFCC loading and our 25 ton loading. Both have been provided. Then
what loading, sir?
DFC and this, 25 ton. You can directly see in the code, or also if you want to see here also it come mobile load vehicle. So we have this 25 ton. Then we have different one you can use. These are different combination available, but you can use one crucial one if you're checking. But we check only these loading. This upper one are old one. Very old, generally do not require. And this is 25 ton. If you use metro one, they change this 25 into 17 ton. Metro loading is pretty much very simple, not that much difficult as this one. And then I have run also. Then I have provided construction stages, material, everything. Not construction stages we are going to provide now. Now what will happen in truss? We discussed the construction stages in previous also. That how yes.
This vehicle means lane assigning how, sir, here?
Lane is only just above the stringer beams, because in railway or truss bridge or railway always there you will have a stringer beam. So if you go into your traffic lane, and if you see my lane 1 will be at this stringer and at this stringer your second lane. I can show you easily. This is my first lane, and lane width will be 1.657. The lane
No,
rail.
we have some minimum distances for highway and also for the railway. Nothing is there.
Yes, railway also is there. The distance between two railway lines center to center is 4.5. Like this
What's
distance I am
Two?
talking about. If you have one railway here, now maybe not able to let me create it.
So can you mute the?
I am not the one. I do not know. Mute will be okay. If you have this one railway and railway is going above it, just assume it, then your second rail will be here. And this distance minimum to minimum is 4.5. This has been given. You don't remember the actual clause, but this is there. So you can provide higher than this, but you cannot go lower than 4.5. Center to center, not from face to face. So generally
if our deck is something from the edge, this
now
much
deck will be at here. You will have ballast. First of all, ballast will come. That ballast have some slope, because 600 depth is required. You need to distribute 45 degrees. So ballast will be here. So generally deck depth, or you can say width, comes around 8 to 10 meter. 8 generally the maximum deck width comes, because you will have some this kind of columns also at this location for carry utility purpose, for carrying all the electricity. That is also required, and some clearance also required for other things. If a bridge, this not column, if this railway bridge also carrying other utilities, other cables or water pipeline or any other thing, it's going to
so
carry.
from outer edge, how much clearance, sir?
From outer edge, no clearance is given. You can provide it how much, but like what I'm trying to tell you, you can consider the same one still, just half of this. Still, this point. This is the minimum, like 2.2 meter you can consider. 2.5 is still higher. So 2 to 2, 8.5 you will get it. So generally you will find out 8 to 10 meter the width of bridge. For my cases, I always seen 9.5 meter.
Okay.
So it can become lower, but if you have ballast-led track, like for metro, it is little less also. Like 8.5 is there for metros, I think 8.5 or 9, because they do not have any ballast or anything. So you can reduce it, no issues. And all cables are inside of your U-girders, and or your column, this electricity column on the parapet of U-girder. So it is optimization thing. We can able to do optimization. But normal bridges, normal steel, railway bridges, you will have minimum 9 meter because of ballast and everything. 9.5 I have designed. No, I know 9.5 is totally workable for everywhere. Not in this, and this 4.5 is acceptable all over the world, because all have this wide, what we call it, narrow, normal, the another one. Forward this name of width. What we call it, track. If I go here. You can apply directly very easily. Broad gauge 1676. So broad gauge always have 9.5 required, because what will happen, sometimes they also provide walkway for inspection, but some bridges do not have walkway. So it totally depends on to your government. Like this is totally decided by your Northern Railway, Western Railway, or any other railways, that how much clearance you required, or if you require some inspection at the time of train running, so people can easily able to walk. So that is the conditions there. So I think other people
Sir,
little bit
this,
get yes.
this other loads directly from IRS code, we can calculate something and we can put it as a sleeper.
No, you will
rail,
not found. Other loads will be your wind load. Other load will
No,
be
no,
your
not wind load. This self weights.
No, you will not find these load in the any code. These are locally available or as per your experience generally. These you will not find anywhere. Generally, what will happen?
Sleeper, rail.
Rail is fine. Rail you will get around 6.1, and this rail fixtures will be 2 or 1 kilonewton. Then utilities 6 kilonewton. These are some things are fixed, but like ballast height sometimes changes, sometimes not. But minimum height they consider 600 mm. So we can provide 600 according to it. Then sleeper also it is fixed, because sleeper are also pre-built available. You can use from any report or anywhere, or you can use from Google search, or you can find out the sleeper weight, rail weights, no issue. These load will be fixed, and other wind load and your temperature load will be same as other measures. Nothing going to be changed. And wind load and temperature.
That is applied already?
No, I have not applied the wind or temperature right now, because first I want to check this thing in. I want to generate the report. That's why I'm not considered right now. I have also, maybe I can show you this model have report.
So regarding the steel composite eye girder,
I have report.
You have
I have that model has some crash or error. So I can show you print result. Yes. If you
Which one, sir? This is
okay, it is already there. Created it.
Truss bridge. Okay.
Not the truss one. Like normal eye girder I've shown you now. I want to show you the output file, that how result will look like. That it is not
for this one only, sir. Steel one, truss
steel
one.
No, steel girder. Truss one I will create it. I am not created, but
steel girder, sir.
I'm showing a steel one because other people can also able to see.
No, steel composite girder on the day there was
steel composite. That is a steel composite. Yes, this is a steel. You can see steel composite one.
Okay. This is for some other model or something else.
I have created another model in my free time. I told you some model error is happening. So sometimes you get error. So you cannot even to identify error sometime in Midas. You just need to create another one. Just leave it. If you stuck in Midas and do not bother it, leave it, create another model. Midas is pretty much.
No, if again it comes, what we have to do, sir? Means we have to find some solution.
Then this is our error. This is our error. So that's what I'm trying to show. I created another model. I got it everything.
Okay. Midas error we cannot solve. Our error we can solve.
Our error, maybe you need help, my help, any senior person, you can able to solve. But if Midas is doing something, so we need to create from a sketch. Midas is not that much good to solving the thing. So if you look at here, everything, first of all, concrete slab, grade, everything they will mention, effective width, how much they are considering, how parameter are there. They will give you everything, the different properties, every as per clause, as per IS 2062 or clause of IRC 24, then 24. They are using every clause. Like IRC 22 is for composite, 24 is for your normal steel, because it will checking your normal steel also and composite also. Everything. Then strength, positive bending moment, negative.
Shear lag effect means what, sir? Shear lag effects.
Shear lag effect, same, the longitudinal shear forces due to this breaking and all.
Top it is there, sir. Above. No,
so
above it is there, sir.
At this level. Bending, there is a negative flexion, negative will not happen, so not required. Transverse stiffener, they will check. Everything, it will check resistance to longitudinal and transverse shear. It will give you every clause, everything according to the code. You can, that is what I'm telling. If you get this thing, you can verify other results if you have your own Excel. If you want to create your own Excel, generally people, maybe if you are very skeptical about, do not want to use the Midas for the design. So you can use this Excel and change the parameter according to your requirement, stress limitation, deflection control, crack width in the superstructure, everything will be here. So
Here
you
for
will get
slab and steel girder, both are designed, or what is
yes,
this,
yes,
sir?
yes. Slab, it will, because slab design, but they do, it checks slab with the steel girder also. It is checking. But still, sometimes it will not check the
Transformed
transverse
section
reinforcement.
properties and all, where it is, sir?
It is checking only in the longitudinal direction, not in. Yeah, so you want to see this transform section. I think that's what I'm telling you. There was short-term composite section, long-term composite section. So here, if you look at the ASY and here, how much it has been reduced. Long-term effect. EC by ES taking 2N. That 15 I told you about. Now this is the steel section. This is short-term composite. Short-term composite, your SIDL. That this is long-term composite. Yes, that will be also this thing. Then crack section properties also there for the longitudinal reinforcement. This generally we do not check, but Midas is also doing. So that is also one
N
more
is
thing.
what, sir?
And is, I think, generally from the long-term effect account, I'm not able to remember correctly. But this is checking that effective width, I told you, no, reducing by 15 and by 7.5. Same thing. I think
Okay.
here, maybe I remember it. Let me go through that thickness. I do not require this. Girder probably gave design. This is different. Reinforcement material. These are your parameters. Okay, design is this is the fine. We need to go in this. Now we can see it. I think it is open. IRC, I need to open. IRC 24604. Okay, let me go.
Sir, links will be there, or it will be without any links, direct values will be there, sir?
Some links are there for okay, but others are direct value.
Forces will be directly entered like that, but
forces and properties
calculations will
directly.
be
Sometime, but not all the time. Generally, all things are directly, but you can connect those dots. If that is what I'm telling. IRC 24. That is mentioned 60. Oh, not seems in the agreement. Where 6. IRC 20. Why? So, in 04. Allowable compressive strain, reinforcement strain, strain. Negative moment. You can see M upon ES upon this thing. Can everybody able to see? This is here M. Should be more than 7.5 or short-term loading or long-term loading 15. Short-term means your live load or long-term means your SIDL or dead loads. So that is, this is mentioned due to short-term loading, due to short-term, first of all short-term, this long-term.
Long term means it should be 2 times of this.
This is it's a 2 time, but 7.5 into this thing 15. You're seeing 7.5 into 15. So that is a normal procedure
Limitation,
for every
sir. Limit.
limitation. Yes, 15. Generally, we more than or equal to. More than or equal to. If you are getting EC upon ESM more than 7.5, so you will consider that, but you never get more than that. You always get 7.5 maximum and 15 maximum. Yes, due to creep, sometimes if
This is actually as per our grade of concrete, no, sir.
yes,
ECM value will change based on
yes,
grade of
yes.
concrete.
Because slab width we are changing, not the steel. Steel will have the same.
ES will be
Even if-
same always. ECM will be changing, keep on
changing.
changing.
Yes.
As per our grade of concrete, M35, 40,
Yes.
45, whatever we are putting that one.
Totally agree.
After this bending, all those things, it will be there, no, sir.
Bending is fine. Bending already there. This is the main properties you require to design a steel composite. This is the one. Or we almost our time completed and you're not able to discuss the steel this one. So if I go into this thing.
So that
here-
Excel can you share afterwards?
If you require Excel, I can give you. In this, still some design has not represented because I just checking myself that is I'm doing something wrong or Midas is something wrong. So because fatigue, you will not find shear strut because I have not considered that time in my design. So when I consider, everything will be there. If you want, I can share with you the group.
What is the difference, sir? You have practiced and whatever the class taken, any difference is there or what we have?
No, sometime what will happen at the time of class, I remain the model open for a long time. I do not close it. So sometime Midas have some internal, I do not know what Midas do. Model.
No, in this stiffener and few other things are there, but
and you
we have
never
not
find out.
modeled
It
all
will
those
give
things. No.
same result, same thing. But if some, I have not even model also. But what I'm trying to tell you, Midas have something again working and working. Sometime error will be there, so it error become permanent. Still, you cannot find the error, and even you solve the error. Midas is like if something will be attain the memory, it will like permanent, like a child. If you teach him one good thing and one bad thing, so he will remember both the thing. Maybe he like bad thing more, but in mind, good thing will be always be there. It will not going anywhere.
No, that
Midas-
SRC property it was asking. No, that it was not asking for you in the next design. Sir, SRC
yes.
property.
No, SRC I have changed it, but still that everything I have changed, whatever the comment was there, but still they are showing the error. So that error
No,
become
in new
part
model,
of Midas.
new model. I am.
New model I have used SRC. I have used SRC. I have created with the error.
With the
SRC is
sir?
nothing. SRC is nothing. SRC is just for your slab will have the concrete and bottom portion will be steel. So nothing that much difference is here.
In the material properties or somewhere we have to provide SRC only. Then
Yes.
only the
Here
steel
also I am
composite will
using
run, sir.
SRC. For this steel composite, I am using this SRC. If you look at here, we have SRC. So we just have two materials, nothing else. So
Two
might
materials,
be,
steel and concrete.
Concrete. Yes.
Same way we have to do for steel composite also. That we have not done it. That's why on the
No, but we have. I have done it a lot of time after, but something happened in that. So
No, in your new model, sir, you have
new
created
model.
one.
I have created a scratch from the SRC, so no error happened. So that maybe they have created some temporary error after which I was stuck. So no issues. We always get. I think we totally have doubt class today, and we do not able to learn new thing. If we go here, time is almost 9. Yes. In stage 1, what we can do in steel truss is totally work differently. You can write down 14 state, does not matter. Now, first of all, I need to differentiate our things also. Like I need to group. How grouping will be done? Truss element will come first. Then bottom transverse chord. Bottom BC, you can mention like this. TC top chord. Then you have a stringer. Then we have bracing. So these all will be requiring here. But boundary group, we will just one boundary group. Permanent one, we are not changing. Okay, provide permanent. Load group, yes, this is required. Now in this, I will use sulfate and some ideal cases. Not all, I will use some. Like I have, yes, green concrete. Then I will have some ideal. Not all going to put. And then we do not have. Okay. So first of all, put the truss. This is my truss and this is my truss. 2 trusses in your truss. Then bottom chord I have. So I need to select only bottom one. Oh, the best method is this. Bottom transverse chord. Then I have a stringer. 3 stringers are there. Then I have top chord. This is my top. No, truss. This is already covered in truss. This. Top chord. Then I have bracing.
Bowstring and this one is very much similar, sir.
Yes. Bowstring is an arch shape, look good. And truss just the normal one. And in bowstring, you can save more steel as compared to your truss. Because bowstring does not have the diagonal chord. They have only vertical chord and arch shape chord.
What chord, sir? Top chord will not be there.
No, top chord will be there, diagonal. This diagonal you will not found.
Okay.
But fabrication wise, this is more simpler because in that we require some curved section, like little bit plate should be curved. So that is sometimes not achievable. Okay, coming to at this. Now here I need to change my support properties, multi-properties, default, permanent. Elastic link table. Change this into permanent.
Here also no temporary supports, sir.
No. You can directly use. Because truss will going to come, they directly put it. Do not require any temporary. Temporary is like nothing. Temporary is like they do not fix to the bearing. But generally, sometimes they always put directly onto the bearing itself. Temporary, nothing. If you are, even you are providing permanent to your structure, no issues. Directly you can consider the permanent. This is I would get it. No sense.
In this case, only all four corners, one bearing will be there. That's it, no?
Yes, yes, yes. Construction stage. It will be changing. I think the time is not here, but slab also will come construction stage. Last, I will put it in that load or okay, ballast I can use in construction, but other load I will put top load. Modified, and this sleeper I will put it directly in that load. So go here, go here. Now in stage 1, what is going to be activated? Only truss. If you activate only truss, it will cause some problem also. Go to back delete this. Truss with some days, maybe 7 days, but do not issue because this is totally a steel one. Add boundary, I can add permanent. Load, self-weight will come. But now what will going to be happen? Can anyone answer if I do this kind of thing? Actually, does it going to work or not? Okay, we will try. Little it will be. Now in stage 2, what you will do? We will be doing top chord and bottom chord, both with 7 days as time. Okay, stage 2 I required it. Does it not created? Cannot create it. Now stage 2, it will be 14 days, but 7 days will be already there. And apply. Now in stage 3, you will have brace stringer, yes, stringer, bracing, add it. Okay. I need to change something. Stringer will come here by 7. Bracing will not come. Apply. Now bracing will be in stage 4. It can be activated 0 days. Now in this, I need to change something. Stage 4 is fine. Stage 5 will also be there, which will be 100 days.
In stage 3, sir.
I will need to update it. Stage 3. Okay, where is stage 4? Live. Stage 5. This I will put SIDL. Now we will see all these stages. If you click here, in first stage, only truss will going to be erected. Okay, no other elements.
Boundary,
like
load.
Truss, in boundary, battery activated, load, self-weight activated. In stage 2, element I will activating top chord and bottom chord. Okay, top chord transfer direction, bottom chord transfer direction. So it will provide more stability. In stage 3, I am activating my stringer beam in longitudinal 1. Then in stage 4, I am activating bracing. In stage 5 is my SIDL. But here one more thing. At stage 2, I will having green concrete load. And it will be removed in stage 4. In stage 4 load, this will be removed. Okay, this is fine. Now the main thing, I have not distributed my loads also. That if you look at this property, this should be self-weight. And this slab. This is my slab. Green concrete. And there is another load, ballast I am considering in SID. Ballast. That is fine. Ballast would be here. Now we have constructed this. We have constructed this. I might get error. I need to see running because I know one thing is not properly. I have to. Yes, we see it. Stability we are achieving. We achieved it. Let me see. In stage 1, this truss have been put. Okay. In stage 2, we have top chord and bottom chord has come. Stage 3, stranger beams has come. Stage 4, bracing. Stage 5, loads are coming all other. Then we have force CS. Now if I go into the results, forces, beam diagram. Now here you can see only this load which I have not defined in this. If I go here, yes, defining clearly, that is a good thing. So now we will continue, and tomorrow I am and I will save it. Now we need to first of all differentiate the composite action, and we need to design this. So these things will be there. So maybe tomorrow I'm able to finish that. And Vignesh, hello.
Sir,
Can you share me on WhatsApp that curve by drawing?
yeah, Devan sir is having. Devan is having. I will just ask him to share.
Yes. Okay. Okay. Kuldeep and Ravi, if you have any doubt also, you can ask. I think Kuldeep generally asks it to me. Ravi is something more. So whatever you have on personal level doubt, you can give us. Okay. Bye. Bye.
बस